Hello, welcome to our section 6.6 lesson for our trig class. We're going to be covering a lot of material here, so it may be a little bit longer video. I apologize, but I want to make sure I cover everything as good as possible. So let's get started. We've got sinusoidal curves in this section, and we're going to talk about amplitude, period, phase shift, and I'm even going to make mention of vertical shift, which we're not going to really do examples of, so to say, but I do want to mention in case you ever run into a vertical shift, okay? So let's go ahead and get that out of the way. It's not in my notes here, but I'm going to go ahead and add it in this empty box here. All right, so if you have a vertical shift, that's going to be either plus or minus D. I'm going to call that letter D. And what that will look like in our equations is you will see a constant, either a plus number or a minus number in one of those equations, and it will be a constant outside of the sine or cosine function. That constant will be your vertical shifts, and plus is up and minus is down. And so later, when we're doing one of these examples, I might actually just throw in a what if, and we'll look at how to deal with the vertical shift when you're graphing, okay? But for right now, we're going to get rid of that. And just know that the vertical shift is going to be plus or minus D, and D would be a constant in those equations, okay? So now, let's talk about amplitude. Amplitude is the absolute value of the lead coefficient. So if you take the absolute value of the number in front of the trig function, that's going to give your amplitude. And since it's absolute value, that means your amplitude is always positive. Next, our period formula is 2 pi over b, and that is true for sine, cosine, secant, and cosecant. And the coefficient of x here, the capital B, is going to affect the period, which is the wavelength, okay? And last but not least, we have the formula for the phase shift, negative C over B, and that's going to involve the constant, if there is one, added or subtracted to the value of x. So the phase shift is going to be determined by whether or not there is a constant as part of the angle, okay? Now then, the domain and range, the domain of any sinusoidal function is always all real numbers. Minus infinity to infinity is all real numbers. And the range is going to be negative whatever the amplitude was, comma, to whatever the amplitude was, okay? And the range are the y values. That's going to be from low to high. You need to understand that if there is a vertical shift, that will also shift your range, because a vertical shift will shift the wave up or down, which that will affect the low point and the high point of the graph. So the range that I have written here as a formula is only accurate if there is no vertical shift, okay? If there's a vertical shift, you'll have to adjust your range. And that should do it for introductory stuff. Over here, I've got the graphing process, which I talked about in my section 6.4 lesson. But if you didn't watch that, just so you know, the sinusoidal functions, I have a 6-step method for graphing. You need to locate your starting point, which will always be on the y-axis. Next, you deal with a phase shift if you have one. Then the wavelength, remember that's the period. 4 spaces, lay out your points, connect the dots. So we're going to go through this graphing process, and I have 4 examples to look at here, okay? So like I said, it may take a little while to get through these 4 examples, but I wanted to cover every possible scenario you're going to run into. Okay, here we go. For this first example, let's slide this up here. There we go. We want to find the amplitude. That's going to be the absolute value of 4, which is 4. There's our amplitude. Our period, which if you notice, I said I'm going to be using a capital T for period. So the period is going to be 2 pi over b, and b in this problem is 2. And so that's going to give us a period of pi. And our phase shift is going to be negative c over b. And a negative make a positive, so that's going to be a positive pi over 2. And so if all you needed to do was find the amplitude, period, and the phase shift, you would be done at this point. And you do need to find those because they're going to be used when we do our 6-step graphing process. Okay, so now step number 1, when you're trying to locate your starting point, that's going to depend on whether you have a sine function or a cosine function. Sine always starts at the origin, and cosine always starts at the a value. Okay? On the y-axis, you're either going to start at the origin or the value of a, depending on the trig function. So we have sine, and so that means that our wave is going to start at the origin. So let's do purple. There we go. So that's step number 1. We located our starting point. Step number 2 is the phase shift. So we're going to need to shift that starting point a distance of pi over 2 to the right. And the reason we're going to the right is because that phase shift is positive. So we're going to come over here. Oh, that looks like about pi over 2 to me. You can judge yourself how wide you want that gap to be. And then this starting point that I drew now is going to be here because we had to shift it, okay? So if you shift the starting point, that's also going to shift the entire wave, which is going to shift our end point, okay? So we've done the starting point, step number 1, starting point. Step number 2, we did the phase shift. We shifted the starting point over based on the phase shift. Step number 3 is the wavelength. And to figure out the end point where the wave is going to end, you always count by the phase shift to equal the period. So I would say how many pi over 2's make a whole pi? And that would be 2. 2 halves make a whole, and that's going to tell me how many spaces to go, okay? So I'm going to go 1, 2 spaces, and that would be 3 pi over 2, because each one of these spaces is a pi over 2. Do you get that? 1 pi over 2, 2 pi over 2, 3 pi over 2. And that would be my endpoint. So I'm going to put a dot on the x-axis because you always finish where you start. And then if you notice, this distance, this wavelength is the period, because a half of a pi and a half of a pi make a whole pi. So that wavelength, that wavelength has to be your period. Now then, I need 4 equal spaces. I've only got 2 from start to finish. So I'm going to cut those in half so that I get 4 equal spaces. The reason you need 4 spaces is because these hash marks are where your points go. I need 4 spaces so I know where to put my next 3 points. Step number 5 is lay out your points. Now, since I'm starting on the x-axis, I can either go up first or I can go down first. That's going to depend on the original coefficient of your trig function here. So since the original number in front was positive 4, that means I am going to go up first, okay? We're going up to 4 at the first hash mark. bam, like so, going up to 4. And that's going to be the hilltop. That's going to be the maximum value of the wave. So the next hash mark is going to return to the x-axis, right? Whatever goes up must come down. And then at the next hash mark, we're going to be at -4, because the amplitude is how high the wave goes, but it's also how low the wave goes below the center line. And then, of course, my last point is on the x-axis again. And then step number 6, connect the dots. Like so. And there's a nice smooth sine wave. And that is one period. That is one wavelength. If I needed another period, I would simply count another 4 spaces. 1, 2, 3, 4. And continue to lay out my points. Up, down, down, up. And I would connect the dots again, okay? Now, if I need any of these critical points, like if I need to know what ordered pair is this up here, I can figure that out because each one of these hash marks is a half of a pi. So from the origin, this hash mark is 1, 2 half of a pi's, and 2 halves make a whole pi. How high is it? It's up at a height of 4. So this ordered pair would be pi comma 4. And what if I want this endpoint? I can figure that out too. I know the y coordinate is 0 because it's on the axis, but then I have to count by halves, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pi over 2, and so on and so forth, okay? So you can graph these graphs, and you can find any of the critical points that you want. And that is done. Let's move on to the next function, okay? Next function, let's find the amplitude. Amplitude is the absolute value of the number in front. The absolute value of -3 is 3. And that is, what does that look like? Oh, there we go, better. Amplitude. Period. 2 pi over b. b is 2 in this case. So our period is pi. And our phase shift is going to be -c over b. Notice how I wrote that. I didn't really want to have stacked fractions. So instead of saying over b, I can say divided by b. So that's going to be -pi over 2. That's -c over b. And then I can do a little keep, change, flip. So we're going to keep the pi over 2 the way it is. We're going to change division to multiplication. And we're going to flip the whole number 2 to make it a half. And then if I multiply straight across, I can see that my phase shift is going to be -pi over 4. That's my phase shift. Now that I have the amplitude period in the phase shift, I can go through the process of graphing. So step number 1, starting point, sine starts at the origin. Step number 2, phase shift. And since my phase shift is negative, that means I'm going to shift to the left a distance of pi over 4. And so that starting point that was at the origin is now going to be here. I had to shift it over. Step number 3, wavelength. How many fourth of a pi's make a whole pi? How many fourth of a pi's make a whole pi? Well, that would be 4. 4 fourths make a whole. And so I'm going to count 1, 2, 3, 4. And then this would be my end point right here. Does that make sense to everybody? Look at this. Here's 1/4, 2/4, 3/4, 4/4. That's 4 fourths make a whole pi. And that would be my wavelength, okay, which is the period. And then what would I label that point? Well, from the origin, I went 1/4, 2/4, 3/4 from the origin. And so I know what to label that point. I count by fourths. Step number 4, I need 4 spaces. I got them. 1, 2, 3, 4. I've got my 4 equal spaces. Okay, so then step number 5 is lay out your points. And remember I said since I'm starting on the x-axis, I can either go up first or I can go down first. And that's going to depend on the original value of a, which here is negative. And so for this sine wave, we're actually going to go to -3 first. We're going to be going down to -3 first. And then I'm going to have to return to the x-axis, okay? And then guess what? Then I'm going to go up 3. And then I'm going to return to the x-axis, okay? So there is our nice, smooth 1 period of the sine wave. And remember I said if I need another period, I would simply go 4 more hash marks, continue to lay out the points, and connect the dots. Okay? And that's done for 1 period. Let's try the next one. And this time we have cosine. Okay? So the amplitude of a cosine is the same as sine. It's the absolute value of the lead coefficient. The period is also the same, 2 pi over b. Uh-oh, look out, b is 3 this time. And that is not going to reduce, okay? So that's going to have to say 2 pi over 3. And the phase shift is going to be negative c, which is negative pi over 2 over b. And then if I do a little keep, change, flip, we can see that our phase shift is going to be negative pi over 6 this time. Yeah, so if you had trouble following that, go back and watch it again. Let me just make sure that I make good notes here. So the phase, let's go back up, okay? So the phase shift, remember, is negative c over b. Negative c over b. And in this case, c is positive pi over 2. So when I plug it into my formula, it's going to become negative pi over 2. That is c over b. And then we do the keep, change, flip, okay? Anytime you have division with fractions, you have to keep the first number the way it is, change division to multiplication, and flip the second number. So that gets us our negative pi over 6 this time. Okay, and so now let's make a graph from this, okay? So step number 1, starting point. This time we have cosine. And cosine always starts at the number in front. So we're going to go up to 2 and put a dot, okay? If I could re-emphasize that. Remember in the graphing process, the starting point, it's always going to be on the y-axis, and cosine starts at a, whatever that value of a is. So our wave is going to start up at 2 on the y-axis because it's cosine. Step number 2, phase shift. Uh-oh, I've got a negative phase shift. And so I'm going to have to go to the left to negative pi over 6. And that starting point that was up at 2 is now going to be here. It's still up at 2, but it got shifted to the left a pi over 6. Okay, so there's the phase shift dealt with. Next, third step, wavelength, which is the period. So how many sixths of a pies does it take to make 2/3 of a pie? Whew, if that's not a mind blow right there. How many sixths does it take to make 2/3? Well, I think it's 4/6. Okay, I think 4/6 make 2/3, and here's why. 4/6 have a common factor of 2. So if I divide 4 and 6 by 2, then I get 2/3. And remember, I got to have that because that's my wavelength. And this tells me that I need to go 4 spaces because each one of these spaces is a sixth. Okay, so here we go. We're going to go 1, 2, 3, 4. 4/6 makes 2/3. Okay, so this distance from start to finish is going to be 2/3 of a pi because it's 4/6, which is 2/3. Okay, now what to label that hash mark? Well, how many sixths did we go from the origin? 1, 2, 3. We went 3/6, but 3/6 reduces to a half. 3/6 is a half, so that would be half of a pi. And remember, I said you always finish where you start. So we're going to finish up at 2. I start up at 2. I'm going to finish up at 2. Now, that's step number 3. Takes care of the wavelength. Step number 4, I need 4 spaces. I got them. Step number 5, lay out your points. So the next point is going to go at the origin, right? Every space, you're going to have to continue the path of a wave. So I started maxed out at 2, so I have to head down. At the next hash mark, I'm going to bottom out at -2, and then I have to head back up. Do you see how these waves work? They're going to bounce back and forth between y values of negative amplitude and amplitude, okay? So this is from 2 to -2. And then if I needed another period, this is one period, I would just continue, okay? 1, 2, 3, 4, down, down, up, up. So easy. So easy to graph these. Once you learn this little trick about counting by the phase shift to equal the period so that you know how to lay out your spaces there. Yeah, fantastic. Okay, so this would be pi over 6, 2 pi over 6. This would be 3 pi over 6. So if I needed this ordered pair, that would be pi halves and 2. Next, this would be, what is that? 3 pi over 6. This would be 4 pi over 6. This would be 5 pi over 6. Guess what this one would be? 6 over 6. There's your pi. And then this last point that finishes out the second wave would be 7 pi over 6 comma 2. Man, I hope y'all understand what I'm saying there. If you don't, just put a comment in the comment section below or text me and you just say, I don't understand that. And I'll lay it out in more detail, I guess. Okay. And I've got one more example that I want to look at. And I think what I'm going to do for this particular problem is we're going to actually look at the vertical shift. And I'll mention a vertical shift in this problem just so you can see dealing with the vertical shift is not a big deal. It's, in fact, once you finish the whole problem, before you connect the dots, then you deal with your vertical shift, okay? All right, so let's find the amplitude. One more time. Amplitude is always positive. Period. 2 pi over b. And b in this case is 2. Again, did you see that? This is the b, which is pi. And the phase shift is going to be negative c over b. Negative c C, S-E-E-C, there's my C. And two negatives make a positive. So this is going to be positive pi over 2. Keep, change, flip. And that's going to give me positive pi over 4 for my phase shift, okay? Now that I've got the information I need, I'm going to go ahead and do the 6-step process, 6-step graphing technique, okay? First step, starting point. We have a cosine. Cosine starts at the number in front. So we're going to go down to -2 and put a dot. And that is the worst dot I've ever drawn, I think. There we go. Put a dot. There we go. Starting point. Step number 2, phase shift. Our phase shift is positive. And so we're going to go over to pi over 4, positive pi over 4. And we're going to put our dots there. It was at -2. We had to shift it over. That's step number 2. Step number 3, wavelength. How many fourth of a pies make a whole pi? Counting by the phase shift to equal the period. How many fourths make a whole? 4 fourths do. So I'm going to go 1, 2, 3, 4. Do you understand what I'm saying? That from start to finish, this distance has got to be the period. And each one of these is a fourth, okay? So this is a fourth, and this is a fourth, and this is a fourth, and this is a fourth. 4 fourths make a whole pi. That's my wavelength. It's my period. And let's get rid of that. Okay? Now then, that I've got the wavelength, step number 4 says I need 4 spaces. I got them. So step number 5 is lay out your points. So we started maxed out at the bottom, so we're going to head up, and now down and down, and to make our smooth wave here. Something like that, okay? Cosine wave. And again, if I wanted to continue that pattern and do another period, I could. No big deal, okay? Real quick, let's talk about domain and range again. So the domain is always all real numbers. For any sinusoidal, domain is -infinity to infinity. Range is going to be the lowest point to the highest point. And you have to start at the bottom first, okay? Range is low to high. So -2 to 2 would be our range. And I think I said I was going to throw in and play what if there is a phase shift. Not a phase shift, a vertical shift, okay? So here's what a vertical shift would look like. What if there was a +2 after this function? It could also be in front here. Whoops. What? The phase shift, no, the vertical shift, it could also be added here in front of the value of A, and it would just say like 2 minus 2 cosine. So it can be on the front or the back. What it is, it's a constant outside of the trig function, okay? It's a number, and it can be negative or positive as long as it's not part of the trig function. It's not the coefficient. It's not part of the angle. It's another constant, okay? That's your vertical shift. That's your value of D, okay? So what we would do if we're going to handle a vertical shift is we would go back up to our graphing technique and we would say step number 7, vertical shift. And you would take care of your vertical shift. Whoops, my bad, dog. Not step number 7. Whoo, that almost was bad. Almost had to redo the whole video just for that, okay? Lay out your points. Step number, let's call it step number 5.5, vertical shift, okay? Once you lay out your points, you would then vertical shift them before you connect the dots, okay? So let's say on this problem right here, before I connected the dots, let's say I had this vertical shift, what I would do is I would take each one of these dots and vertical shift them. So this one up 2 and this one up 2. And then 1, 2. And then this one up 2 and this one up 2. Do you see what I'm doing? I'm simply translating every dot that I plotted according to the vertical shift, and then I can do connect the dots, okay? And you're going to notice you get the exact same wave as we had before. It's the exact same shape, except it's shifted up 2 units. That's all a vertical shift does. It just shifts the graph up or down. Now, that will affect the range. So the range, whoops, let me make sure we color code this correctly. The range of the green graph, which is the vertical shifted graph, now would be 0 to 4. Because now the lowest point that it gets to be is 0, and the highest point was 2, now it's at 4. So do you see how a vertical shift affects the range? Doesn't affect the domain, but it does affect the range of the graph, okay? And just to re-emphasize that in the graphing process, that does occur at step number 5.5, okay? Lay out your points, vertical shift them if you have to, then you can connect the dots, okay? And that should do it for this particular lesson. So I hope all of that was helpful. If you have any questions or comments, please put those in the comment section below, or you can text me. And thanks for watching.